Shall we start now?
Yes.
Okay. So today's topic will be laws of motion, friction, circular motion. All three topics will be taken together because all are conceptually same. The only way of writing equation will change, nothing else will change. Now, laws of motion will have basically two parts. One is the ABD part, which you are aware of. That is called the constraint. So my initial focus will be on constraint actually, because constraint is an integral part of not just laws of motion, but even if you want to solve the question of work energy power, you should be really good, really good with the constraint. There are some forces which you should be aware of. So I hope you all know the spring force. You know the tension force. You know the normal reaction. You know the friction. But in friction, we have two parts. I differentiate as kinetic, static friction, and kinetic friction. And these together are called contact force. So when I say the word contact force, you have to think about normal and friction both. Okay. But this is called basically surface contact force. This is all three. If I take all these three together, I mean, in fact, all. This is called contact force. But the last two is called surface contact force. This is called point contact force. Point. So here surface is not required, but these two are surface contact force, and it is like a distributed force. So this concept is called the distributed force. So you may represent by single arrow, but it doesn't mean it is acting at one particular point. It is acting throughout the surface. And then what you locate is something like a center of force. There's a concept like a center of mass. So you have center of force. So you just apply it there. So for example, if I draw a wedge. So in case of wedge, tell me how the mass is kind of distributed. You can see the mass is more on the right side and less on the left side, isn't it? So
Yes.
the normal acting on the right will be more than normal acting on the left. Because the ground is pressed more on the right and less pressed on the left. And therefore, there is a concept of center force. And if I assume this to be a perfectly uniform mass and if the shape is triangular, if I say the base length is A and this is B, we know center mass is there, right? A by 3 and B by 3.
Yes.
So this is A by 3. Okay, this is B by 3. And for any triangular shape, I mean right angle triangle, this is the center mass. So the way the normal acting is everywhere, but how to represent it? So we represent always below the center mass. So in general, because our idea is to also apply the same concept in a rotational dynamics. So you should know that the normal acts below the center mass. If it is not below the center mass, what will happen? If you do not consider this to be below the center mass, what will happen?
There will be a torque acting on the body.
Yeah, so the body may topple also. So because we know that gravity acts at center mass, so they are collinear, therefore they are not creating any torque, and that's why the wedge is stationary. Okay, so if the wedge is stationary, this is always the idea. When you are solving laws of motion, definitely you do not consider such a intricate position thing. You just draw the normal and you're happy about it. But now because you have finished the entire syllabus, you should be aware that normal is not acting anywhere. It is acting below the center mass if it is at equilibrium. As the situation will change, For example, let's say if I give some velocity v naught, then of course it's a rough surface. So the moment you do so, okay, let me draw a separate one, not to confuse you with the same diagram. So imagine if I draw the same diagram and if I've given some velocity and also I'm saying there is a constant, there is a frictional force. Now friction will act like this. Okay? And this is just a kinetic motion. This is the center mass. Okay. Okay. Now, if I draw the normal here, is it correct? Should we do normal like this? Yes or no? So what is in the normal will be at the same place as before, or will it shift left or will it shift right? Think about it in 10 minutes. Tell me.
It will shift towards the right.
Correct. So now what we do is the moment you have multiple forces and you want to analyze how it should be acting, always think about the torque. If it is not turning, see, it is translating, but that's not an issue. If the wedge is not turning, if it is not rotating, it means the net torque is about center of mass. So now about center of mass, friction is trying to create torque like this. This is the torque of friction. But if it is not rotating, then the net torque is zero, which is only possible if the normal will shift right of it. Then only it can create the torque like this, correct? So in case of motion, the normal will shift and will create a torque which is going to balance it, and it will exactly shift by the value which is creating the torque. So we know that N is equal to mg, and in fact, because of the torque relation, you can say Nx must be equal to Fk into, if I say this is B, this is how much, if you remember? Fk into, come on, tell me. B by 3, right?
Yes.
Because the torque is about center mass, and the distance of center mass to the line of action of force is B by 3.
B by 3.
And the x, this is itself mu into n. And in fact, you can get the x value, it is mu b by 3. So how much it will shift is mu b by 3. Understood? Imagine if the separation is not sufficient, if this is less than a by 3, what will happen? It means the normally is not getting enough space to shift actually.
The body will topple.
It will definitely, so the moment you throw it will topple.
Okay.
It will never be at rest. So the moment you try to give some velocity, it will just tumble down. Okay. So the same concept, that is what we study in rotational dynamics as the effect of tilting. So toppling is a concept which we study there, but if you understand the basic equilibrium condition, you can always analyze on your own. So these are some basic things that you should be aware of, that normal and friction are distributed force, which means they do not act up at a point. They are self-adjusting in nature, not just in value, but also in position. Is this clear? So static and normal. Static friction is self-adjusting and normal is also self-adjusting. It will act what it requires. Okay? How much you need, it will act accordingly. So for example, imagine sometime you might have seen in the classroom that a teacher trying to rub the blackboard using duster. The duster, simply slips out of the hand of the teacher. Anyone seen that? No.
Yes. Yes.
So it used to happen with me very often. Okay. But that is a very nice problem. Okay. So imagine this is the vertical wall. And of course, it's a rough surface. Okay. And this is center mass of the, let's say this is a brick, and mg will act like this. Okay, how the friction will act? So, okay, I'm trying to press it. So first of all, I will be pressing this brick exactly. I'm pressing exactly at center mass. So, what is the torque due to the F?
0.
0. And torque due to gravity force, mg,
0.
is always 0. Because we are talking about torque about center mass. Now, how the friction will act? If the tendency is to slip down, friction will act.
Upward.
Let's say it is at rest. This length is A, this length is B. So, yeah, B. So, how Fs is trying to create the torque? Fs will create torque like this, clockwise.
Yes.
So, if someone will consider normal acting at this point, will it be correct? Or should normal be acting above this point or below this point? What do you think? How the normal should be acting? Above this point or below this point?
Below.
It is
Below.
definitely below. Because there is no choice left. And the reason is again obvious. To balance the torque. Now, in laws of motion, this we never discuss because that is called the particle physics. So dimension is ignored. And because we ignore the dimension, the torque concept goes away. But the moment you switch to the chapter of rotational dynamics, the same normal, same friction will become really a difficult force to analyze. But if you have the right perspective of analysis, you can always analyze no matter whether it's a rigid body or it's a particle. So normal will shift downward. And now for equilibrium, what you can say, Fs is how much? So vertical force, if you balance that, Fs is mg. And if you balance the horizontal force, F is how much? N. So can we find Y? So torque about center mass must be 0 because it is not rotating. So what you can say? The Ny must be equals to Fs into A by 2.
Yes.
So F into Y equals to mg A by 2. So Y is how much? Oh. And you can clearly see that as I will increase the F, the Y will decrease, which is logical. If I apply large force, then the normal needs to shift by less value because N is more. It will create a bigger torque easily. So the same normal, the same friction you have seen in locomotion, but things will change there. But anyway, this is part of rotational dynamics, but you can always understand here. So what you need to understand is that friction and normal are self-adjusting and a distributed force. In fact, all friction forces are which force? Distributed force. Is this clear what I'm saying?
Yes.
And you could always think in a similar fashion, like how the distributed force behaves. Okay, anyway. So we'll go back to laws of motion, and especially I would like to talk about the constraint quickly. So let's talk about the constraint. So I hope the force is clear. Like what are the forces? Spring force. What is the spring force? It depends on the deformation, right? So because it is proportional to deformation, then what you can write? K into
Yes.
deformation. X is called deformation, which means initial natural length, and then we take the difference with the deformed length. The difference is called deformation. So every spring will have natural length, some length without deformation. And spring force having the tendency to always oppose the deformation, right? So if you compress, it will try to go back to original position. So it will create which force? Pull or push? Okay, so spring force is the force which is always of opposing behavior. If you compress, it will push. If you elongate, it will pull, right? So spring force can be pulling nature or pushing nature both. But what about tensile force? Can it push? Tension force can be only of which nature? Pull or push?
Pull.
This is only pull. This is pull
Pull.
plus both. Normal. Normal.
Push.
Only push.
Push.
And the friction, you don't know. I mean, there's no way to say that's pull or push. So it could be anything. So these are the forces. Okay? These are the forces. You should know the meaning of it, how they act, and what they do in what circumstance. Constant. So now I'll talk about something called constant force. I'm making it very, I mean, messy. Okay. What is the constant force? Constant means some sort of restriction, right? You restrict the movement in one way or the other. So, for example, if you have a two-person holding the same rope, and if they're trying to run, can they run freely? Can they run freely?
No.
So they can run freely if the tension is zero, right? If the rope is infinite length and then you're holding the two ends, and no matter how much you travel, it is always loose. So the loose rope or string or thread will not create the constant, but a thread or string with tension force, which is like a taut string concept, will create the constant motion. So constant means when something is taut, when the string is taut and it is inextensible, so you cannot change its length. Okay. So the moment you say inextensible, you put a constant actually. So the word inextensible and taut string creates a constant motion. So tension force is called constant force. What about normal? Is it constant? Is it a constant?
No.
It is always a constant force because when you walk, you don't go inside the surface, right?
Yes.
You go parallel to surface or you go inside the surface. What do you do?
Parallel.
So now there is a concept that surfaces are rigid. So for rigid surface, you are not walking on the Mars line. So for rigid surface, the normal will act as which force? Constant. It will prevent someone to dent the surface, isn't it?
Yes.
Okay. So you need to realize that when two surfaces make some contact, the normal is putting a constant. Why? Because it is not allowing to go inside. The dent is not possible. Do you realize this?
Yes.
So to maintain the contact throughout the motion, if the surface will, let's say, descend by some value y, the object can only descend by y. It cannot descend more than y, isn't it? And if it is not descending by y, but less than y, then there is no contact. But that is not the question. The question is to maintain the contact throughout the motion, the normal will put the constant only. So normal is definitely a constant force. It creates constant. And the third constant is which friction? Static or kinetic?
Static.
This is also constant force. So these three forces in physics are called constant force. Understood? Remember? Which one? Tension, normal, and
Static.
Fs. So this is called which force?
Constant forces.
Now Fs is putting the constant in which fashion? It is preventing the relative motion. It means if two objects are in contact, just the two blocks, and if I know that these are moving together, then of course they are accelerating also. So if this will travel by x, this will also travel by x. Why? Because we are saying that friction force is here is static, which means there is no relative motion. So Fs will make sure that there is no relative motion. It is clear. So generally, when you say that objects are moving together and the cause behind the motion of the one object is friction, this must be static friction, right? So if M dash moving together, and if M is moving due to the friction between the surface, which friction we can think of? Only static, right? Why only static? Because there is no relative motion. It is clear. If there is a relative motion, then which friction will come into picture?
Kinetic.
And kinetic friction is the surface can skid, the surface can move relatively. Then such situation will not come under the concept of constraint. Understood? So we have three types of constant force. You should remember only these forces are called constant. There is no other force in nature which we call constant. It is clear about the concept of constant force to everyone?
Yes.
Yes.
When you go to chapter of work energy theorem, then work done by internal constraint force on system is always zero. Why? Because they always act in pair, right? So first of all, every force will act in pair. The internal force will come in pair. So if one force is like this, other will be like this. Am I right?
Yes.
And if the displacement is going to be same, so one will do the positive work and other will do the negative work. And therefore the network is always zero. So that is why when you're solving a question of work energy theorem, and when you're writing the working theorem for the entire system taken together, for example, if I have a two blocks M1 attached to M2, and if this will go downward with X, this will go right with X. Do we need to consider the tension work for writing the WET for the entire system?
No.
If I am taking M1 into a system, then we should not think about which force?
Tension.
Tension. So only gravity will come, friction will come. Okay. So you have to always remember these as a fact that internal force on a system cannot produce work. And this is what we talked about in working film, that the role of the internal force is to what? What is the role of constant forces? What is the role of internal constant force? Anyone? What is the role of internal constant force?
Sir, to relate the motion of two bodies with respect to one another.
Oh, that is, of course, the motion will get related. But what is their role in terms of work energy power chapter? Like when you are doing the work energy power chapter, we
Sir,
know that.
the
Yeah.
Direction of work done.
Pardon?
Sir,
Work done is
Okay, one by one. Okay, you tell me. Yeah, Mukta, go ahead.
To understand like the work done is positive or negative, that way.
No, that is not their role. Okay, Hasika, you tell me.
Sir, energy lost by one object will be the energy gained by the other object.
Correct. So it's called the redistribution of energy.
Yes.
The constraint is always desirable to redistribute the energy because the source of energy is not at one place, but due to the constraint, you transmit the energy. So all the gear system, uh, all the chain system are meant to transfer the energy from the producer to the different parts. So if we talk about something called chassis, right? So every vehicle, even your bicycle will have a chassis, a frame, what you call frame. And the frame is a rigid substance. It's a rigid structure actually. And the purpose is that you can kind of throw the power from the point where you create to other parts of the body. So constant will help in transmitting power, and a better design of the frame or the chassis will transfer it effectively without any loss. And why we talk about this kind of frame, the effective transfer will take place if it will follow the laws of physics. So we have to be understanding the concept of energy transfer by virtue of constant. But of course, we do not study in that fashion. That's why it is not very obvious to us. The role of internal constant force is to transmit energy, or not transmit, to redistribute the energy. So what happens if M2 will go down by X, it will be, the gravity will work how much? M2G into X is the work done by gravity. So what you need to realize that the gravity is doing work on which mass? M2 or M1?
M2.
Gravity is only doing work on M. But it is a tension which is taking a part of that energy and giving back to M. So the work done by the tension here is negative. So it is taking away the energy from the M2. M2 is getting energy from the gravity, and this energy is distributed, which means it is now going to deliver to the M1. So the same tension acting here will do the positive work, which means the energy taken is actually supplied here. Now you can see the energy transmission happened without any loss because the tension is internal constant. If you have the extensible string, what will happen? The energy cannot transmit effectively. Why? Because the elongation of the string itself will store some energy, isn't it?
Yes.
So the string will act as the spring actually, isn't it? And therefore, some energy will go to the spring, and a part of energy will go to the what?
Block.
Block. So if I draw a diagram to demonstrate the same concept, if I tell you that I have a block attached to a spring passing over a pulley, and now it is attached to the block M. If it will go down by X, okay. So if it will go down by X, then gravity will give you energy M2X. Tension will take some energy, but now you cannot say the same energy will reach here, right? Because in the path we got something, energy storer. Understood? So if M2 will go down by X, M1, let's say go with some X1. Okay, so how much energy is, kind of obtained by M1? Can you guess? It is only Tx1, right? M1 will receive Tx1, but how much M2, how much energy is taken by the tension here? So tension is consuming how much energy? Tx. So out of Tx energy, the block is getting Tx1. So where the rest energy is going? It is getting stored in the spring. How much? Do you realize this?
Yes.
See, I'm just doing it organically without using any formula. I don't know what is the formula, but you can do it this way. And the x minus x1 is for the elongation, isn't it? So this is the elongation. So the moment we have non-constant force into picture, the energy transfer will not be efficient. It will be kind of a fractional energy will reach there. The rest part of the energy may either get dissipated or may be stored by the system. So these are the ideas that you have to, generate to have the holistic view of mechanics. So don't think of only one chapter. If you are learning something, you have to apply everywhere else. And this way of thinking is very powerful. But constant force, the meaning of constant, the purpose of constant. And the moment you start thinking this way, it will be easier for you to write the equation in a comprehensive manner without getting confused. Okay. Anyways, because I'm not teaching you the working powers, I'll just leave it up to here. But is the concept of constant and non-constant force clear?
Yes.
Yes, sir.
So what is the role of constant force in concept of energy?
Redistribution of energy.
Redistribution of energy without any loss. And because their only job is to redistribute, so even if I create a very complex system, just to confuse you, and if I say this goes down with X, no matter how complex I design, just to scare you, the gravity will give how much energy? M1 gx to the block, and the entire energy will reach here. Understood? The entire energy will reach here without any doubt.
Yes, sir.
The constant will only decide the speed actually. Okay. So if it goes down with x, if the velocity of the first block I call v1, it will have velocity v2. And now you have to understand how to find the v2. So you can name the tension as T, you can write like this T. So T, 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 so this is 2T. So how to write the constant? So the block is experiencing, the M2 is experiencing how much tension? 3T.
Yes.
So in time dt, how much you will move actually? V2 dt. The displacement will be how much? V2 dt of the block. So force into displacement is called energy. Correct?
Yes.
So tension has given how much energy to M2? 3T V2 dt, isn't it? But that energy has come because of 2T has taken how much energy? 2T has taken how much energy? 2T has taken
Two.
V1 dt energy. So in time dt, the block A1 will go down with V1 dt, isn't it?
Yes.
So the tension is acting upward, you're going downward, so you're extracting energy. So 2T will extract this energy and will give to this guy because it's a constant relation. And we know that tension cannot store energy. So no matter how complex I design, the purpose is that it will transmit the energy. Understood what I'm saying? Is this clear what I'm saying?
Yes.
And you can clearly see that dt will get cancelled, all t gets cancelled. And we know that 3v2 is equals to 2v1. And this is you call the constant relation. See, the constant relation comes from the energy relation. So the purpose of constant is to transmit work. And then because this is the actual idea, which we enforce to the small, bits when they come in class 11th, we never teach this way. What we say that remember that tension dot velocity is 0. Why we say this? This is the consequence of constant relation. It is the consequence of energy transfer, right? So why T dot V must be 0? For a system connected with history? Because internal force cannot do work, right?
Yes.
Internal force cannot do work. So what they do? They kind of transfer energy. So this is the actual method. This is the actual method. But this is how you learn for the first time. Because that time you're not aware of the work energy power chapter. So what we say that just write the T dot V relation and make it 0, will get the constant. So kind of we force the student to mug up. And I say that, okay, you have to wait till working power chapter to understand the basic reason behind this. Is this clear? Now, this is if you apply directly, what will write? 3T V2 because the dot is angle is same. So it's 0 cos 0 plus 2T V1 cos phi because the angle is 180, right? And if you make it 0, we'll get the 3V2 minus 2V1 equals to. So this is what you do generally, correct? Isn't it?
Yes.
Hello. So the concept of internal constant force is very, very essential. One should be aware that when to apply, when not to apply. The moment if I introduce one of the spring, then this is really painful. Now you should not apply this method, the T dot B. Why? Because it is now the attach of when you attach a spring, you make it extensible string. A string which is extensible cannot put constraint. It is the inextensible string which will put the constraint. I hope this is clear.
Yes.
Yes, sir.
So imagine if you come across any ABD in which you must have seen. Just to save time, I'm drawing a bad diagram. So forgive me for this. So again, the constant will be here also, right? So if this will go with V1, this will go with V2, isn't it? And you can write the tension. Tension, if I say T here, what is the tension here? 1, 2, 3, 4, 5, 6. So 6 T V2, T V1 equals to 0. V1 is 6 V2, right?
Yes.
And because this is a constant relation, we can differentiate further to get the acceleration relation. So here AM becomes 6A2. Now remember, this is not constant. This is constant. Constant is only meant for what? Acceleration of velocity.
Velocity.
Constant is only for velocity, but in many situations, it looks similar to the, the acceleration relation also looks similar as the velocity relation because of there is no angle involved. But if I draw something like this, let's say we have a bangle. Okay, I'll apply. This is a new question. So this string is almost touching the pole. So this is almost like this, but anyway. And this angle is also. This ring is not attached to string. String. It is actually passing. So the string, red string is passing under the blue ring. Is this clear? Okay. And this is coming down with velocity v1. This is going up with velocity v2. Can you relate v1 v2 at this instant? So string is touching the ring. the blue ring is touched by the string for sure, and it is taut. So what will be the relationship between V and VT?
Sure, along the string velocity should be same, right?
Hmm. So the string here is fixed.
But the part which is taut, so
The entire part is taut.
okay.
Hmm. Okay, done. Only write the work any theorem. The Walton tension is here. That's it. That is sufficient. So if you draw the ABD of the blue ring, the blue ring will have two tension, right? One like this, another like this. Do it like this. Maybe. And the red ring will have tension like this. And the direction of motion is upward. This is downward. So can you solve now? Can you solve now? The constraint. So what is the work done by tension on the red ring for the small time interval dt? You know how to write work done, right? Force in the direction of displacement into displacement. So what is the line here?
T V2 cos alpha dt.
V2 cos alpha dt. Oh, dt I'm ignoring because I know it will cancel out. So done. And what about the other?
Sir, TV1 cos alpha minus 1 dt.
It is like t cos alpha minus t into v1, right?
Yes.
Into dt. Is this correct here? So what we are getting here answer? V2 cos alpha equals to V1 1 minus cos alpha, right?
Yes.
So this is the energy way of creating the constant, and this is later on you will come to know this called the principle of virtual work. So in the principle of virtual work, we mentally display something by dt for the dt interval, and by displacing it mentally, we write the work done by the internal constant force, and because it's a constant force cannot do the work, so it will be always zero. So that is called the principle of virtual work. But if I do not want to use the principle of virtual work, the T dot V relation, do we have some alternative? So the most fundamental constant relation is the length of the string is constant, right? Can you solve by the idea of length of the string is constant? Is this concept clear? This part is clear to all of you? Yes or no? Tell me.
Yes.
Everyone?
Yes.
Yes, sir.
Clear?
Yes.
Yes, sir.
So now imagine, so I'll introduce a new method called the IDM. What is IDM? If you have seen the old videos. Increasing, decreasing. Why just name this? So this is what I created by the name. Increasing, decreasing method. We know that the length of the string is constant. So if any motion will try to increase length of the string, the and other must decrease because the net is going to be zero. So I'll try to demonstrate this on the easy question first. So let me introduce the toughest question of constant relation. If M2 will go with speed V2 and M1 will go with speed V1, M2 will increase the length or decrease the length of this segment. So there is a concept called segment, which means if you have a string passing over a pulley or it is bending or turning, we break into segments. So we count the segment first. So we only see the two segments. Imagine these segments are virtual rubber band. So V2 will elongate the rubber band or shrink the rubber band. What will happen?
Elongate.
So it will elongate at what rate? The rate itself is V2.
V2.
V2 is called the rate of increment of the segment on the right. Okay. What is the role of V1? It will increase the segment or decrease the segment.
Decrease.
Decrease.
At what rate?
V1.
V1 itself.
Minus.
So when you increase, we write plus. When you decrease, you write minus. The sum must be zero because it is not a rubber band. It's a dot string. So the increment and decrement must be same, which gives you the answer. Okay, this means the A2 equals to M. And that's why you say, let's say the access is A for B. This is what we do. Now, if I apply the same idea, the V2 is directly going to affect how many segments? Can you count? 1, 2, 3, 4, 5, 6. 6 segment is connected with V2 directly. Do you realize this?
Yes.
So when V2 will go
Yes.
up, it will decrease the 6 segment minus 6 V. And V1 will increase the only one segment. That's constant. So if I apply the same idea here, the V2 is trying to move this way. What is the component of V2 in the direction of this segment? Because V2 is connected to this segment, right?
Cos alpha.
And it will decrease or increase.
Decrease.
It will decrease.
Decrease.
So minus V2 cos alpha is the decrease. Done. Now V1 is connected to two segments, this and this segment. So the upper segment V1 is going to increase or decrease.
Increase.
And the
Increase.
V1 cos alpha will
Decrease.
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 be the same also. So the increment decrement method is a very powerful method. You can apply anywhere and you can get that. Understood?
Yes.
Okay. So now imagine there is a very interesting question. If you have the laws of motion sheet from resonance, do you have anyone? Have?
Yes.
Just open it. Okay. So open that sheet, everyone. And you can see there's a constant section D must be there, constant relation. I think it's exercise 2. Yeah, question number 12. Page 24 of video. Can you see that?
Yes.
So it is a typical question of constraint. In fact, I'll tell you what are the questions you can solve with constraint. 9, 10, 11, 12, 13, 14, 9 to 14. Either you apply the work nature, what you have learned, or if you are not comfortable, apply the increment, decrement. Okay, you'll get the answer. So solve the question. You can leave 13 because that is normal question, but you can do it. It's not difficult. Solve this question first, then I'll go to the next question. I mean, next one. 9 to 14, quickly. This chapter is all about constant, nothing else. I mean, the rest is you can always do. So you all have heard the question? You all have the booklet?
Yes, sir.
9 to 14. Solve in next 6 minutes or maximum 7. 6:40 I'll start. So I think ninth can be done very easily, either by the T dot V, what idea, or by the increment decrement, isn't it? How many of you have done ninth?
Done.
After ninth, you can attempt 11th, and then attempt 12th, and then 10th. So they are easy, no? 10th requires something slightly more. And 10th will also make it clear that that acceleration is not a constant velocity. It is the velocity which is constant. Okay, how many are done? Ninth done. Okay. 11th,
Yes.
11th you did.
No, sir. 11 doing 12th I got done.
12th you got the answer.
Oh, yes. I think I have got the equation.
What is the question? Send me.
Okay.
Send me the question, then I'll just check. Just how many you did?
2.
You can. 9th and
Trying 11th.
mm, But how can all be positive? Can you think about it? Murga. You written everything is positive. I think some
Yes.
component will be negative, some will be
Negative.
positive.
Yes. I will check. 1 minute. So the first should be negative. I think.
Hmm. Correct.
With that, I'm getting answer.
Yes.
sir.
Yes, Muga, tell me.
Sir, I'm not getting the 10th question.
10th question. In 10th question, you have to apply the same work done part. And from the pool, you can find the tension in every pool. So if you assume tension TU in one of the string, the other string you could find the tension also. That's easy. So let me show you. You think about it, but you can go to the next question. I'll show you. Okay, so I think you have got enough time. Now it's my turn. Ninth is done. I think ninth everyone has done, right?
Yes.
Yes.
So in the 10th one, how many string do you see? And for one more concept that you can always apply. If a string is taught, and if you know
There is only
the
one string.
if you know the velocity of the two ends,
Along the rope, it should be same.
then along the rope it should be same. Why?
To keep it taut.
To keep it taut. Either it will break or it will become loose. Okay, so
It's
V2 cos
because
beta will try to extend it, and V1 cos alpha will try to shrink it, but both must be okay. So in a taut string, the only relative motion that you can observe is the rotation. So one with respect to one, the two can only go this way. Perpendicular. Right? Because along the string there is no velocity, so you can see the perpendicular velocity, right? There are two component velocity V2 cos beta. This is V2 sin beta. And this is V1 cos alpha. And this is V1 sin alpha. Okay. Now this string can only rotate if one will observe two or if two will observe one. The string will rotate. And what is the angular velocity of two with respect to one? Omega to one will be in this case particularly
V2 sin beta minus V1 sin alpha.
Plus
V2 sin beta plus V1 sin alpha.
V1 sin alpha.
And if you
While L.
Sorry,
it is going to be plus because the relative is going to add it up, right?
Yes.
So omega will be there, which you can add as g theta by dt of the rotation. Okay. So this is going to be the idea in a single piece of string. And in the question number 10, if you look at the, and this is a very typical question that again we have not seen those videos. Okay. So looking to this quickly. Bad diagram. Let's see. So this end is trying to go down with speed u, right? And this end is trying to go up with some velocity, right? Which is not given. That's called v. And because of
Yes.
symmetricity, I know that it will go only upward. So that's angle is theta. And this will become the single piece of string. So v cos theta is equal to u. That's it. So what is v? U sec theta, correct?
Yes.
And this is going to be okay. And as you go up, this segment will shrink. That's called y. So tan theta is how much?
D by Y.
Dy. So y is how much?
B cot theta.
So what we do is we differentiate, because to find the acceleration, what you do? You simply differentiate the velocity. So dv by dt is how much? Because u is cos
Minus
theta,
B cos x square theta.
sec theta tan theta into this right?
Yes, sir.
I hope you all know the differentiation.
Yes.
And the problem is we don't know this value d theta by dt. So for that we have to do a trick actually. So yeah, you know how to do this. You can differentiate dy by dt is b minus cos x square theta d theta by dt. And you know what is dy by dt? It is the as the particle, this particle will go up, the y will shrink, right? So dy by dt is basically minus b
minus
into omega. So this will give you the omega equals to v by b. So we just substitute here. The axis is u sec theta tan theta into v by v sin square theta. But v itself is how much? So u sin theta by cos square theta into v, which is u sec theta by b into sin square theta, which is nothing but u square by b sin p by cos p, which is so this is the relation between the acceleration and the initial. So you can see that the other end is actually moving with constant velocity, but because of the angle involved, this 2 will not move with the uniform velocity, it will move with the variable velocity, so it will have acceleration. So that's the answer B. Okay, 10th is clear.
Yes.
Yes, sir.
11th, anyone getting the answer for 11?
Yes.
Yes, sir.
12th,
Yes, sir.
Yes, sir.
Yes.
13th,
12th also.
Yes, sir.
13th also, 14th.
14th, I'm unable to do.
Anyone who has done 14th?
Sir, I have
No.
to attempt 14th.
Okay, so 14 is again, it's a simple trick. We just add the ratio. Okay. So we know that all distance will be in the ratio of the side length of the rhombus, right? At least proportional. So how far is A3 from the wall? So I can say wall as O. So OA3 I can write, you know how I can write? I can write as something 5K, 3K and 2K, which is 10 into K times. Not exactly 10. It is 10 into some number which we don't know. Correct? Hello, hello, hello. See, if you draw a rhombus, if it is some length L, then this length will be 12 cross theta, right? But only side is decreasing, so angle will remain same throughout, right?
Yes.
So if I say L1, L2, L3, so the overall length will be in terms of L1 to L1 cos theta, to L2 cos theta, to L3 cos theta. So it's like the ratio. So it will come in a way to L1 plus L2 plus L3 plus something like this. And because it is given the ratio of something 5K, 10K, 5K, 3K, 2K, if you add all these things, you get something 2 cos theta into 10K, right? Which is eventually like 10K dash, because I can take K into cos all as correct. So what I'm saying is eventually you can attach OA3 equals to 10K, right? Similarly, you can add OA2 equals to how much? 8K. And OA1 equals to 5K. Now take the ratio. So the ratio remains always same, right? So the ratio will not change and it will be independent of the angle theta, isn't it? So OA2 by OA3 is how much? Tell me guys. OA2 by OA3 is 8 by 10. 0.8. And this ratio will be same, constant. So OA2 will be 0.8 OA3. And if you differentiate, this is the velocity of 2. And V3 is given to you, right? V. We simply play with this.
Sir,
Hmm.
could you show how to do the 11th one with like T into V method?
11th one. If you assume the tension on the right string, and if you do the FBD, the plank will experience how much tension? 40, correct?
Yeah.
So you can
Yes.
do mentally. So 40 is acting upward, right?
Yeah.
So let's say it is going up with velocity v. So the work done is how much? V dt like this.
Yeah.
And if you look at the person's hand is moving towards left, right? I mean left and right both. So this is the two end of the rope. This is going with u dt. But the
Yeah.
tension acting here is T only, right? But if you look at the left one, the tension is not T. It is 2T actually. Do you realize this? It's a different
Okay.
string.
Yeah.
All string is same except the left one.
Yeah.
And if you look at this pulley, the pulley which is hanging on the left side, leftmost side, this is T. Do you realize this? The same is going here, isn't it?
Yes.
So now just think of the work done of the forces. So the work here is this is positive work.
Yeah.
40 VDT is positive minus 2T UDT negative minus T UDT, all are negative, right?
Yeah.
So 4V minus 3U question. So V is 3U by.
Okay. Okay.
You can always do this way, and always remember that whenever there is a free end, the end which is by kind of pulled by someone, we always look at the end as the object, and therefore the tension is like this always, and then check the displacement. Okay. So I think all are done. Correct? All done. Yes or no?
Yes, sir.
Now I'll go
sir.
somewhat deeper into this constraint part, and now I will involve the spring into calculation. Because the actual constraint which we face is the spring question. Yes, someone is saying something. Parv, you want to say something?
No, sir.
So this will also be helpful for the SHM and work in theorem. See, in fact, SHM and work in theorem are very close relative because both can solve in the energy method. So most question of the SHM can be solved by the force, torque, and energy method as well. So if you know one, you can of course do the other. So imagine we have a spring. And now I have a pulley with mass. So it is not just a pulley, it's a pulley with mass, and let's say this is K1, this is K. The string and the spring both are like connected together. So now you need to understand something. Whenever we have a spring part of some string, what remains same? What remains same? So the tension
Can you
force
repeat?
remains same. Whenever you have if you draw a string and then you draw a spring attached to here, then again some string, then the tension level will be same for all. Why? Because our spring is massless. And what is the property of massless object? You know what is the property of massless object? The property of massless object is that the force can transmit through it without diminishing. That's the only property. And it is like the force will not face any resistance. Rather, the force will affect the deformation of the spring. But whether we talk about the tension connected, so the tension in the string connected or tension in the spring, which we can call the spring force, all are going to be same. What does it mean? Look at this. Imagine we have a string, a long, and then we have some string, and I'm applying a force here. So what is the tension? What is the force acting here at this knot? The force here will be F only. Why? Because the force which we are applying here will transmit through this medium and will arrive at here. And while the force will transmit it, a massless object in between cannot affect. Do you realize this what I'm saying?
Yes.
Force can transmit without diminishing if objects are massless. Hello, 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 hello.
Yes.
And this
Yes.
is what exactly you do here. When you say massless pulley, without this much relation, when you say this is T, this is T, this is massless, so the same force will transmit on the other side. So one side force and the other side force cannot be different because it is massless. Let's say it is having mass, and this is, you don't know the answer, you will say this is T dash. Let's say M is not 0. What to write? T dash minus 2T equals to mass into acceleration. Laws of motion, correct? Hello, hello. Hello.
Yes.
And therefore, if I say M tends to 0, T dash equals to 2T. So for massless object, net force is 0. Does it mean acceleration is 0?
No.
No. So the acceleration will be governed by the constant, not by the laws of motion. Hello, hello. Is this clear?
Yes.
Yes.
So for massless object, we never find the acceleration using the laws of motion. We find the acceleration using the constant relation. That how much it can go actually. When you say a pulley is smooth, then only this is correct. Because when something passes over a pulley, and if it is a rough surface, while coming on the other side, tension will change. So if this is T1, this becomes T2. This is T3. This is mass. So this is the rough pulley. So whenever pulley is rough, when you make contact with a rough patch, the tension will change while going from one side to another side. Why? Because the rope will have tendency to slip, and whenever there is a tendency to slip, what will happen? There is a tendency of a relative motion, and friction will act. Yes or no? So let me show you
Yes.
the rough pulley with string passing over and how we think about the force. Okay, just let me show you something interesting here. And everything comes from the laws of motion concept. Nothing more. The purpose is to demonstrate that how you will think in the chapter like rotational dynamics. So if I consider a small segment And if I simply zoom this segment, you see the string which is passing over. And let's say you apply a force, let's say tension on the side is T. But as you move d theta away, the tension changes to T plus dt, right? And
Yes.
not only this, because let's say if the tendency is to go this way, frictional lag, D. And there is a force also acting, normal, D. So basically, if you write the ABD, because it is massless, what you can write is T plus dF equals to T plus dt. So the incremental change in the tension is due to the incremental friction acting on the string. Hello. So when you say
Yes.
smooth, when you say the word is smooth, this becomes 0.
0.
And that is why the tension, there is no incremental change in tension. Do you realize? Another
Yes.
question is
Yes,
how to find the dn. So dn you can always write as, when you calculate the dn, you can take this as t and t only roughly. So this becomes t d theta. Do you know this fact? dn is t d theta.
Yes.
So if you have studied the wave and sound, for any arc,
Yes.
this is t. The net inward force is t d theta, right?
Yes,
Yeah.
And this will
because
balance
of
the d.
small angles.
Small angle. So therefore, the t dt is df, and therefore dt is mu dn, and dt is mu t d theta. So dt by t is mu d theta, and therefore this is very interesting. If it, on the lesser side it is t naught, and on the other side it is t. So the t becomes t naught e power. And this concept is so powerful that if you go to any jetty of ferry, the moment the ship, cruise or whatever, when they come to the shore, they throw a rope, and the rope is wrapped around a pole. If you have seen, I don't know whether you have experienced this or not.
Yes.
So they do it
Yes.
as fast as possible, because when they make a turn, imagine the wave can pull the boat, maybe this side. But once you have a pole, and once you wrap this current, this becomes very powerful. So the force that I need to apply to, kind of pull the boat is very small. So a single person can pull it. The rest is supported by the friction. And you just need to apply how much force. So you're applying T naught here, but how much tension is coming here? T. And that's what I'm saying. You pull by T naught, but because of the exponential rise of tension, the boat is experiencing how much force? T, which is mu times T. So even if you wrap 2 times, and let's say mu is, let's say 0.5, let's make it simple. And if you make 2 wraps, so which is like 4 pi, how much is that? E power 2 pi, right? And E power 2 pi is enormous value. It's not a small value. So it is 6.28, and E power 6 is roughly like 3 power 6. So you make it roughly close to 1,000 times more, right? Let me calculate this. E for 6.2. It is roughly 533 times. Imagine if you apply a 10 Newton force this side, I mean, of course, I can apply, you can also apply. In fact, you can apply 100, since you can 53300 Newton. And that much force you can balance. So you can imagine that why it is so powerful. But anyway, the purpose was not this. The purpose was when you say the word is smooth, when you say the word massless, there is a consequence of every literature. Everything which you say will have a consequence. And of course, the question which I have derived is a very famous question of the winding of rope around a pole. And in most of the Olympiad question, you will see this kind of question very common. So you should understand these things, that why tension will vary when it is not smooth. And that's why when you're solving question of rotational dynamics, we always assume T1 this side and T2 this side, right?
Yes, sir.
And then we say
Yes.
that, okay, let's say there is a alpha, and we say the net torque about the center is T2 minus T1 into R equals to ICM into alpha. Do you remember this equation? Very famous equation.
Yeah.
Yes.
Okay. So that idea is always there. Massless and massive will have relation. Rough and smooth will have a relation. And when you are solving question of rotational dynamics, the same laws of motion will come there also. And there the pulley will become massive pulley. Pulley will have mass. It will have moment of inertia. And your answer will change a bit. So if you remember that the typical Atwood machine, the answer was M2 minus M1 into G, right? If you remember.
Yes. M1.
And then I by R square, if you remember this. The
Yes.
massive pulley question, where the I is the moment of inertia of the pulley. So when you are solving question, just keep in mind that from the laws of motion till the rotational dynamics, there are subtle changes. So you should know that what are the changes that I need to be careful about. So what we don't consider here and what we need to consider there, everything comes from the definition only. So the word like smooth, inextensible, massless, all having some consequence. So just try to remember these consequences, that under what condition what is not true. So if you solve blindly, you will make mistake. But if you understand what is going to be possible mistake, you can prevent that mistake. Is this clear?
Yes.
So now the question, okay, I was trying to explain something here. The spring question. When something is massless, okay, this we went much ahead. When something massless, then what is the concept? Remember, a massless thing will allow you to transmit force. Okay. Now, of course, here the string is massless, but there is a contact, and contact creates the friction. That's why the force is not getting transmitted equally. Okay. You realize this. So massless doesn't mean that force will transmit. Massless without contact will transmit force without diminished. I hope this is clear.
Yes.
Yes.
So what happens? What happens if you are solving question of errata? They will give you the same simple question of a pulley with Atwood machine. And then they will bring a change in the question. They'll put a wall like this. And will tell you that wall can create a friction. So it is like your with your right hand, you kind of in your fist, you hold the rope. So if you hold rope with your fist, and if you hang the two heavy masses, what will happen? It will still accelerate, but it will rub against your hand, palm, right? Is it?
Yes.
So if I consider tension here, that same tension will be appear till this point, but beyond this point, this will make a change. So here the tension become T dash. Do you realize this?
Yes.
Yes, sir.
It is no longer T. Okay. So the moment you make a contact in case of string, beyond the contact point, you will have the change of tension. Okay. So let's say if I say that M2 is going down with acceleration A, M1 will go up with A, but the ABT will be quite different. It is T actually. It is T dash. It is no longer T. So what I'll do, if I just cut this part, and if I kind of draw the ABT, imagine this part I am removing, the string I am removing here. And I'll draw the ABD now, just to demonstrate. So the tension here is T. The tension here is T dash. And because the string is trying to slip upward, the friction will act.
Down.
So basically, T is T dash plus F. This will be your relation, and this is the error question. Do you realize how to solve?
Yes.
Yes.
So what you're going to write is you will write M2G minus T equals to M2A, and you will have T dash minus M1G equals to M1A. Okay, and then you will write T minus T dash equals to F. They will give you F. How much F is that? They will give you. And then of course you don't solve. Try to add. If you add, the T gets cancelled, the T dash gets cancelled. So what you get here? M2G, M1G, correct? Equals to M2 plus M1 plus F into A. So A becomes M2 minus, okay, no, M2G, okay. So you got it, right? M2G minus M1G minus F upon. So of course you can see there is a change in the answer, the way it is written. So you're not supposed to solve question blindly. You have to think a lot actually. And if you are able to think at this level, then you're into the JEE advanced English. So you have to always consider every terminology very clearly, that when someone is saying something, it means something. Do you really understand the meaning, or you have been solving question blindly? So make sure that you don't solve question blindly, because you have done something like this similar in the past. So you know this is solved this way, but you have no logic. So the concept of tension, massless, smooth, all are clear. Okay.
Yes.
How force gets transmitted is clear.
Yes.
Yes, sir.
So now, when the question of spring comes, I mean, many students feel scared that how to start with. What is the starting thinking process? But it is very easy. So I'll start with this question. I'll take a massive, and this is paper. The first of all, the rope, this rope, if I just go through this journey, this entire part is massless object, right? And in a massless object, we cannot have two different tension. Okay, it is passing through the pulley, but if it is smooth, then we are worryless, right? Because if it is frictionless, then tension will not change over the side, correct? But if I say the mass, if this is like a disc and the disc is not slipping, oh my God, then tension will change on the two sides. So this could be a question of a regular SHM. This could be a question of a rotational dynamics, in which I will say that, okay, the mass M is not slipping. Amazing. This is possible. Yeah, it is not slipping. Quite possible. Do you realize what I'm saying? So it can just, kind of roll down. And it will come down, it will pull the spring by different elongation. So I'll come to that part later on, but let's start with the easy version. What is the easy version here? In laws of motion, we always go for the easy version, right? So the easy is smooth, massive pulley. So it's not massless, it's massive. So it is having mass. Okay. So it means the rope will slip over the pulley. And what I'm saying is the tension force throughout the string will be same. So we have to choose a parameter which is constant in nature. So we call T. Okay. Now, a spring cannot have tension unless it is not deformed. So, what do you think? The spring will elongate or compress itself? What do you think? So
Elongate, sir.
T will be your universal variable. You will write universal parameter, which I will keep always, handy for solving question. So T is universal, but K1, K2 has to elongate to actually, contain that tension or transmit that tension. So when you say tension is T, the spring will be under the effect of force T, and therefore each will elongate as per their K value to manage the T value. I hope I am clear this part. The elongation in each spring will be in such a way to to create a tension which is common for the entire string. Is this clear?
Yes, sir.
Yes.
And therefore, the x1 will be T by K1, next two will be T by K2. What is the energy stored in the spring? Energy stored. The potential energy in the first spring will be half K1 x1 square, right?
Yes.
But actually, the tension is common for all. So this we can also write as, what? T square by 2K1. Isn't it?
Yeah.
Hello, hello, hello. And U2 will be how much? Just so this way of writing of energy is okay, clear?
Yeah.
Hello, hello. So now generally these kind of questions we come across in SSM, right? But anyway, so this is the thinking. Thinking process is what? Yes. Very good. Okay. So the first step of thinking is thinking of the common variable which can relate everything. So how much first spring will deform, we don't know. How much second will deform, we don't know. But we will know one thing, that it can be expressed in terms of T. And therefore T becomes like this. And therefore the energy stored can also be calculated. So how much energy is stored, you can see clearly. It is so you can see something. Energy is getting stored, stored square of the tension, right? That's very interesting. Okay. So that will do the trick part. Okay. So we solve many questions in tricks. So I'll show you the trick later on. Now, next part. If this will elongate by x1 and if this will elongate by x2, the pulley will go down by some value x. Do we know the answer? How much it will go down? So that is called the constant relation. That individual deformation of the spring and the descent of the mass connected should be related to each other. And that is purely constant. What is that constant? Any guess?
Sir, x is equal to x1 plus x2 by 2.
You all know this answer? Or do I need to explain this part?
Yes, sir.
Okay.
So could
I
you
know
say?
this.
What you need to realize that, see, a pulley will go down only when, if let's say pulley goes by X, this segment will grow by the initial plus X and so grow by.
Yes.
So the total growth is required is how much? 2X, no?
Yes.
Which means if I know the total growth, it will descend by half of this.
Yes.
So the total growth is 2X, but how much I have descended? Only half of
X.
this. So how much is the growth here? X1 plus X2.
Yeah.
So how much I can go down?
X1 plus X2 by.
Only half of that value, right?
Yes.
Yes.
So this is very organic way of thinking. So X is always X1 plus X2 by 2. And this is how you start the constant relation. So you know this tension, this powerful, you know this relation, and what you do next. So the spring blocks system or spring pulley system, this is at rest in the very beginning. It means it will have some deformation which we are ignoring actually. What we do is we always deform beyond equilibrium mentally. So we say X1, X2 is deformation beyond elongation. Hello, hello. Do you realize what I'm saying?
Yes.
Yes,
When
sir.
you deform beyond natural deformation or the initial deformation, the tension will grow beyond the initial tension. So when we solve question of SHM, we make the T as the beyond value. This is beyond, this is beyond. Everything is beyond the equilibrium state. So the T is the called the tension force developed beyond. Beyond what?
Equilibrium
The
tension.
equilibrium tension. Yeah. So everything here is the actual delta. This is delta. Okay. So delta is kind of inbuilt, which I don't represent just to make it look simple. You can make it complex by writing delta and doing all those complex calculations. Eventually, that will lead to the same idea. Okay. So the whole idea is you can write the constraint and use the this method, because if you write the laws of motion of this block, what is the net force acting on this block in this pulley? In terms of universal variable, it is 2T upward,
Yes.
and 2T will act as which force? A re-string force, isn't it? See, the initial forces are balanced, so we are not writing at all. So I'm not writing mg. Do you realize what I'm saying?
Yes, sir.
I'm writing beyond the balancing part. So the extra tension will act as which force? A restoring force, isn't it?
Yes, sir.
And because that will act as the restoring force, so what you are going to write? You are going to write like this. You will write as net and the acceleration equals to minus of a restoring force upon mass. That's it. One line answer. Or you can say minus T by M. But you must express the T in terms of what? In terms of displacement of the moving mass. And that is where it will help. This equation will help you. So what we do is, because I need to express in terms of X to solve question of a system, we need acceleration versus displacement, right? So what is X1? T by K1. I hope this is what we discussed, right?
Yes.
So T, if I take common, it is 1 by K plus 1 by K2 is 2X. What is T by K? T is 2X upon. And this is what we substitute here. So what do you get? A equals to minus 2 by M. Into And so the answer is and whatever you multiply with x, it becomes
Omega.
and this becomes a question of SH. So it will go through this constant relation. Okay.
Yes.
Yes.
Now, what is the trick part? I said there is something like trick. So trick part is, I think I have missed something. This is Q. X1 is V1, Q1. Fine. Yes, now from the trick part. Whenever you are solving question of spring and block, and there is a large variety of spring, you can always replace by a single spring block system. And now we need to know what is the K equivalent. So your original problem is this. And we would like to convert this into a simplified problem of single spring and single block, because we know the answer of time period of omega t. This is 2 root m by K equivalent. So how to get the answer directly? How? How to get the answer directly? Any guess?
The tension is equal in both the springs, so we use that to find the K equivalent.
Yeah, so the tension is acting T here, T here. What is the tension for the M mass?
2T.
M
2T.
for M mass it is 2T actually. So the tension experienced by the moving mass, if you call as E experienced, is 2T. The tension in the spring is half of that value, right? Hello, hello, hello. The tension in the individual spring is only T, but tension experienced by the moving mass is 2T, right? So what is the
Yes.
factor? What is the factor? It is half. If you go from here to individual spring, it is half the value. Correct? So there is something called factor, and factor here is half. So the way of writing this, 1 by K equivalent is how much? Factor square by K1. Factor square by K2. I don't know what is the factor for each, but here it is same for both. So what is the factor square? 1 by 2, which is 1 by 4 K1. Sorry. 1 by 2, so 1 by 4. Factor square. This is correct. So the time period will be how much? 2 pi under m by k equal, which is m by 4. I think this is same answer. No, this is looks different. This is how to write this? You can do by omega. Yeah, that's correct. Same answer. So this will act as a direct conversion method for any spin. So the answer is 1 by k equivalent is summation of factor square by, and the factor is decided by the moving mass. Like we need to first check how much moving mass is experiencing the tension, and then we convert when then we find the tension splitting part, how much factor it is decreasing or increasing, and we use the formula. So we can do some problem to just get the hang of it. Okay, so this is massless pulley. Tell me what is the time period of this oscillation? What is time period? 3.0 m by k. So what is 1 by k equivalent here? Any guess? Or how to start with?
So with the tension on each spring.
With the
So with finding out the tension on each spring so that we can use the trick.
so we have to first, okay, always it is good to assume that tension on the moving mass first. See, so moving mass is m here. Let's put tension as T here. So this tension will come here directly. T only, right?
Yes.
But this
Yes.
will come T here. Okay. So you know what is the actual reason for the trick is the energy conservation. Nothing else. This comes from the energy conservation. Conservation of energy. Nothing. And how it comes, if you remember that in the pre, okay, I'll first solve this, then I'll come to the how it exactly comes. So 1 by k equivalent is how much? For the k1, it is same factor, no factor is 1. But for k2, the factor is 2, right?
Yes.
So your answer is done. This is the answer. Just substitute the here answer. You got the answer. The time period is how much? 2.0. 1 by k plus 4 by. It is clear.
Yes.
But anyway, let's think about the total energy stored in all these things. What is the energy stored here? The energy stored is T square by 2k1. If you remember the formula.
Yeah.
2t whole square by 2k2. And if I replace by a single spring block system, so the energy stored is how much? T square by 2k equivalent. Do you see the energy stored formula? Energy is stored. So when you replace by single equivalent spring, it should store the similar energy as before. Hello. Is this clear what I'm saying?
Yes, yes.
Yes, sir.
Yes.
So this all gets cancelled and you can see clearly why the answer is correct. It is coming from where? Conservation of energy stored in the spring. Now let's apply the same idea. You just realize this part. It can take 1 or 2 minutes to understand. Then I'll go to the previous question just to show. In the previous question, the tension is 2T, right? So what is the energy stored here? 2T whole square by 2K equivalent.
2K.
What is the energy stored here? P square by 2K1 and P square by 2K. And I hope you realize this. Do you realize it is 1 by 4 times 1 by 10 to the power 8?
Yes, yes.
I think this is a better one. Like even in examination, instead of using a trick, write the energy. Because that will not go wrong, right?
Yeah.
So the energy is stored in the given configuration. We equate with the equivalent configuration, and that is how we find the K equivalent. I hope this method is clear.
Yes.
I mean, of course, you're not
Yes, sir.
supposed to mug up. You're not supposed to mug up. You can just apply this method. You will always get the K equivalent with ease. And so the time period is very easy to find. So let's say if I give you a question like now you will not falter. You can just answer this with ease. Can you answer this question? Not difficult. Just try this. So I will assume tension here. So this tension is T. This is 2T.
2T.
So you got the answer. No? It will come 1 by, so 4 by K2 plus 1 by K1. Right? Is one of it. This is the same answer. We have done this.
Yes.
You can pick any question from the world and you can find the time period with ease. Is this clear?
Yes.
But this trick is only when someone is asking for the time period and all. But when it comes to the question in which they ask the intermediate values or something which in which you need to show the dependency on x, you have to use the constant plus log of motion to get the answer. So I hope this constant part is clear. How the constant is, I mean, used. So I'll just show you something interesting. So constant is, let's say I want to write the constant for the block. So I'll say this will elongate by x2, this will elongate by x2. Always assume the elongation. Can you relate x1, x2 with x? What is the relationship between this x? Simple trick is assume one deformation at once and see the effect on x and add all them algebraically. Yes.
Sir,
Yeah.
sir, x2, I mean, x is equal to 2x2 plus x1.
X equals to 2x2 plus x1 is the right. How many of you are able to realize this concept?
Yes, sir, got.
Yes, sir.
This is the most crucial step because sometimes we need to express the tension as a function of x. So what is the t as a function of x? So it's very simple. You know how to do the next step. Replace x2, x1 in terms of t, right? The universal variable. So how much is t? Tell me.
K1 X1.
Right. How to replace the next step will go 2 times x2 is what is x2? Come on, what is x2?
2T by K2.
Every spring will balance the tension. So
T by
K2
K2.
x2 is K2 x2 is 2t, right?
Yes, sir. 2T by K2.
It is 2t by K2, not t by K2. And x1 is
T by K2.
so basically x is here 4 by K2 plus 2 by K1 into 2. So T is basically here how much? K1 K2 x upon is this clear?
Yes.
Yes, sir.
So as the block will descend, what is the work done by tension? Minus t dx. Oh, I'm saying distance. Isn't it?
Yes.
So they may ask you find the work done by tension. The many question, see what I'm saying is you will not always get the one single question. You can get question in which you have to understand the intermediate relationship, how to write it, how to exploit it, the condition. So that's why I'm saying that you should learn the constraint first. If you're good with the constraint, the rest you can always get. If you know only the trick, you know only one answer, isn't it? In JEE Advanced, knowing the one kind of answer is not sufficient. You should know the process plus trick. Because if the question is only for the last part, apply the trick, get the answer as fast as possible. But if the demand is to understand the intermediate answer, then it will be slightly complex. So I'll just take one JEE Advanced question. So I have shared the JEE Advanced.
Sir,
Yes.
sir, why is like multiplication of 2 applied for the entire bracket?
Oh, that's a mistake from my side. So that's why I was thinking why it is coming closely. I should not. Even I was wanting to see it. Anyway, I hope you got the idea.
Yes, sir.
Correct?
Yes, sir.
Okay. So let me show you the question. The JEE This is very interesting problem. I have shared on WhatsApp. Please check everyone. So this is a very good example of a constraint work and everything else. So read the question and solve everything.
Question 2, right?
I have shared only one question.
Ah.
When angle is not involved, then the acceleration relation and the velocity relation will be similar. So you can treat A as V and write the constant, you will get the same answer. I think D option will get very easy if you understand basic. Let's say. And do not take the relative motion at all. Just write the ground same answer. Get the answer. Okay, just done.
Sure, do it.
See, when you get a new question, when you don't see any hope, always go from scratch. Apply the basic. And that is your strength. The trick is only for limited question. The basic is for one. Because here we have only one spin, so there is no concept of a question of finding K equivalent because we have only one. So that is not the case. Okay, so don't try
We
to
should
think.
find the tension first for
Yeah.
the
So
lower
you
pulley system.
correct. So always start with the constant. Whenever you solve a question, you should start with the constant first. So write the constant.
Yes, the option is correct.
D is correct. I think if you got D, then you will get a lot of things. So write the laws of motion. Uh, just write the laws of motion. You get the answer in terms of T. And the T is anyway connected to the spring force, so you know you get the answer. Can you do this? And you can realize that every time we have to substitute in the constant relation, not anywhere else. Gaurav, Darsh, are you guys doing?
Yes, sir.
So this is your JEE advanced examination going on, right? Not more than 10 minutes.
Yes, sir.
You can use equivalent weight, right, over here.
Pardon?
I'm using equivalent weight. I'm combining those two down blocks.
Mhm.
And one we can get from directly equation that 2A1 is equal to A2 plus A3.
So do we really need to find the equivalent weight, or we can just solve the way we know?
Wait, I'll try.
See, are you guys able to write the constant first?
Yes.
Yes. D option we will get from constant directly.
So if you know the constant, simply substitute the laws of motion, net force equals to mass into acceleration. So A is how much? Net force upon mass.
Okay, understand.
Every A can be substituted in terms of universal variable T, right? Always learn this concept, how to create a common variable. And I think T is the best way to do it, right? Hello.
Yes, sir.
Yes.
So now proceed. See, eventually you have to write the laws of motion, which is very simple. Net force equals to mass into acceleration. If you don't write this, then I can't help much. I'm not going to teach you laws of motion, how to write FBD and how to, only the key concept. So that was the whole idea of revision. You get something which you do not see very often. That's it. And JEE never asks difficult question. That's the first thing. JEE means solve from scratch. That's it. What happened? Shall I solve now?
So just a second.
So you all will get the answer. Just carry with the basic, believe in the process, move forward and get the answer.
Sir, the first option is not the answer, right?
No, first
Yes,
is
first
not.
is wrong.
First is wrong. I think only two options are correct. But how to get the answer, I don't know. This is 20, 19, JEE-Mains. So I need to find the answer. I don't know where it is. Answer we can find in the textbook. So first to solve. We'll see the answer somewhere it will be.
Sir, are you speaking anything?
No, I was just writing down. 2 plus 1 plus 4, right? 1, 3, 4, 7. Okay, I haven't read the question. I'm just solving from the diagram itself. So P is 4m by 7 into 2g plus. Okay, this is the tension force I'm getting in the upper string. Okay, what did they ask question? The tension will vary as per x, right? So when the spring achieves an extension of x naught by 2 for the first time, the speed of the block connected to the spring is. So work done by tension is how much? E dx.
Sir,
Hmm.
in this question, we can't find tension for the below pulley system by the formula we know 2m1 m2 by m1 plus m2. From that.
No. Because the pulley is not at rest, no?
Yes.
So we
Okay.
should not apply.
Yes.
It's simple.
Okay.
So what I did was I just simply wrote the laws of motion for each mass. And I use the constant to see whenever we have more than 2 acceleration, it is always convenient not to solve, rather to substitute in terms of common variable. So as I said, the t is the common variable. So I'm assuming that what I have written is correct. If something is wrong, just let me know. So okay. So the work done by tension is TDX, and what is the work done by spring? Minus half k square. Correct? So this is the net work done on the 2m mass. So the net work equals to change in kinetic energy, half m v square. That's it. So 8 mg by 7 into x, which is x naught by 2. And what is x naught? I don't know what is x naught. Okay, maximum elongation is given, right?
Some extension of.
Okay, so for maximum, we know the answer, right? For maximum elongation, it will be 0. The change in kinetic energy is 0.
Yes.
So 8 mg x naught by 7 plus 4k by 7 x naught square by 2 minus k x naught whole square by 2 equals to 0. That's 8 mg by 7 2 by 7, na? 2 k x naught by 7 minus k x naught by 2, right? So 1 by 2 minus 2 by 7 into k x naught is 8 mg by 7. 7 minus 4 is 3 by 2 k x naught equals to 8 mg. 7 gets cancelled. So x naught is 8 mg, 16 mg by 3k, right?
3K. Yes.
That's why the first option is incorrect. And if it is okay, now we know this is x naught, so you can apply the same trick to write the working equivalent. So you can write 8 mg x naught by 2 plus 4k by 7 x naught by 2 whole square by 2, which is 1 by 2 into by 4 minus 1 by 2k by 4 equals to half 2m v square. Can you solve this part? 8 mg x naught by 2. Okay. X naught is how much? 16 mg by 3k plus k square by 2 40 minus k square by 8 mv square. Oh, I mean, of course, I can give it. Fancy. Not fancy. This will remain, no? Oh, not fancy. Anyway, so you understood what what we need to suppose to do is this in v square. Can you solve this part? And substitute the x naught. Tell me what you are getting. C you can easily get, right? See the axle, the extension when x naught by 4, the magnitude of accession of block. So T minus a x naught by 4 equals to 2 into a. And T to anyway, no. T how much we need? 8 mg by 7 and 4k by 7 into x naught by 4. So 8 mg so kx naught is 16 mg by 3. चौबीस और 40.
Sir, the other term minus kx naught by 4.
Pardon?
Sir, there's another term minus kx naught by 4 in the equation.
Okay, have I missed something? Okay, see the tension we got this one, right?
Yes.
Can you all
Yes,
check
sir.
the tension value from the equation, laws of motion?
Yes, sir.
P by 24m and T by 2m and kx by 2m. So this G plus G is 2G plus kx by m, correct? And then T 1 by 2 and 1 by 4m and 1 by m. This we can add. LCM is 4m, so 2, 1, 3, and 4, 7. That seems correct. 4m by 7 into 2g plus 4m by 7 into kx by m. So 8 mg by 7 plus 4 kx by 7. This is correct. This is correct.
Sir, I was talking about the minus kx naught by 4.
Okay, I'll just remove this part. I mean, let me do this on this page. X naught is correct.
Yes.
Yes.
8 mg x naught by 7, 4k by 7 x naught square by 2 minus half k x naught square equals to 0. So 1 by 2 minus 2 by 7. Kx naught is 8 mg by 7, which is 3 by 14. Kx naught equals to, this is fine. So Kx naught is 16 mg by 3, and this is correct. This is correct. And if something is not correct, I think it may be here.
Sir, no, sir. In the most recent equation that you solved, I'm referring to.
Okay, this one.
Sir, no, sir.
This one.
Yes, sir. You forgot to substitute for minus kx naught by 4.
Yeah, okay, fine. So I'll write it here. So what was that? Okay, so what was that? Okay, so this I was solving for what? For which part?
Sir,
D
C
part.
option.
C part.
C option. C part. No? C part is T minus Kx naught by 4
4.
equals to 2m into A. And T is how much? 8 mg by 7 plus something. 4 kx 4 x naught by 4. Correct? Now I remember. This is what I left, right?
Yes, sir.
So 8 mg by 7 plus kx not 1 by 7 minus 1 by 4 2 ma and 8 mg by 7. What is kx not value? It is 16 mg by 3.
Yes.
This is 7 for 28 and this is minus 3, right? Correct? So 8 mg by 7 minus 4 ja, and 7. Okay, fine. So it is 4 mg by 7 is equal to 2 ma. So A becomes 2g by 7. Maybe the first answer itself is okay. What is the answer? I think only one answer is matching. Very bad. So C is not matching. What about D?
D is matching.
No, B. No, B, D, B. Boy, B for
Simply
boy.
I have to solve.
So B is what? T dx minus half x square. Sorry, x not about 2, right? Yeah. So 8 mg by 7 x not by 2 plus 4k by 7 x naught square by 4 minus k x naught square by 8 is mv square 4 mg x naught by 7 k x naught square 1 by 7 is 6 mv square 4 mg by 7. Okay, what is x naught? 16 mg by 3k.
3K.
Fine. Extreme. Okay, so I think no answer is matching. Huh? So anyone having the answer for this?
Only
Yes.
D is matching.
D is matching. Only D is matching.
I got D.
No, DA everyone got. But did you
D
solve
is
for the
like
other?
the first equation.
No, what is the answer given? I think only one answer may be correct. Quite possible.
I don't know the answer. You don't have the answer key.
No, you can just search on Google and get the answer. So I will just see what is okay, because this is maybe one more answer is matching. Let me read the question. Yes, I'm writing once again. If I missed something, MA1, right? And MG minus G by 2 equals to MA2. And 2mg minus G by 2 equals to 2MA3. And A2 plus A3 is 2A1, right? So this is the simple pulley constant, if you remember the pulley constant. And now what I did was I simply substituted the value of A2, A3. A2 is G minus G by 2M. Just to make sure that I did everything correctly. G minus T by 4M. And A1 is T minus so 2G T by M. This relation seems to be correct, right?
Yes.
So 2G plus Kx by M is T times and M 2M for M, LCM is for M 4. Oh, that's correct. This is correct only. So 4 to the 8 and G by 7. No, this is correct. This is correct only. So nothing is wrong. So every answer, okay, I think only one answer will match. All three options are incorrect. I remember this. And why they made question like this when everything is incorrect, I don't know. But anyway. That is the only answer. The D. You can check.
Yes.
JEE Advanced Physics. JEE. Anyone having the 44 years PDF?
Yes, sir. Yes, sir. I will
You can check now. You just check. Because I have the old one till 18. 19 is not there. Yes, Mugdha, you saw the answer?
Sir, only one is correct.
Only one is correct. I
It
know.
is shown.
So that was a really bad question because only one is correct and
Only
so
one
many
is
others.
correct, and that was the easiest.
But anyway, you should know how to solve. Okay, now we'll go to the next concept called the wedge constant quickly. So wedge is basically the constraint due to normal edge. So we all have seen this very famous question of the rod and the wedge. Just a minute. And there is a vertical rod. And there is a support which will prevent it to fall left or right. And the support is frictionless support. Okay, so there is no friction at all. Okay. So which normal is the internal normal reaction between the masses M and capital M? So we do have normal here, but is this the internal constraint?
No.
Because this is not at all internal, it's external to the system, because M and capital M is our system and ground is external to the system. So first thing we need to realize that not all normals are internal. Okay, so this is eliminated anyway, but still I'll draw this. I'll call this as N1. Okay. But we can clearly see there is a constant, there is an action reaction pair between the masses and acting in this fashion. So on the rod it will act this way, but on the wedge it will act this way, correct? Because of the physical constraint, the ground is offering you constraint. Do you realize this? You cannot go this way. The wedge cannot move this way, isn't it? So how the wedge will move? There's only one way. Horizontal, right? Parallel to the ground. Hello, hello, hello.
Yeah.
So wedge will only move parallel to the ground.
Yes,
You can
and the rod
name
will
it-
always move perpendicular.
And rod will always move vertically downward. You can think as V2 and V1 as of now, because constant we write for velocity, not for acceleration. But in this case, it will turn out to be similar for both because of the constant theta. Anyway, what is the work done by this force? So this force is acting like this. I can draw a theta here. So this is also theta. So what is the component of normal in the direction of velocity? You can clearly see n cos theta, isn't it? And it is upward. And V1 is downward. So the work is positive or negative?
Negative.
How much? V1 dt? From very scratch we are solving. And what about the same normal on the wedge? So the component of this will be n.
Sin theta.
And what is the displacement in its direction?
V2 dt.
And now you know the answer. The minus V1 cos theta is, so basically V2 sin theta is same as V1 cos theta. So I can call this as Vx, and I can call this as Vy. It looks nice. So Vy tan theta is Vx. Sorry. N sin theta into Vx. Yeah. Oh, I made a nomenclature here. Fine. So V2 is what? Vx. And V1 is Vy. So what you get is Vy equals to Vx tan theta. So we can always do every question from the principle of virtual work done, which we know that it is always valid, and it simply says that the work done by internal constant force is always 0. But this tedious method you are not supposed to apply every time. Just think of the n dot v. But the better way is, because at one time only two surfaces can be in contact, we write the constant for two surfaces at once. So the theory says that because you cannot dent the surface and you cannot leave the surface, you have to maintain the contact. Therefore, the displacement along the common normal must be same for both. So the simple rule is what? Displacement or velocity along the common normal must be. So for which this is what we generally use. Displacement along the common normal must be equal. This is the most fundamental idea in case of constraint relation of a normal constraint. So you can write very easily. What is the component of V2 along this normal direction? So V2 is like this. And what is its component along the common normal? V2 sin theta. Correct?
Yes, sir.
And V1 is downward, right? What
Yeah.
is the component of V1 in the same sense of normal? See, we keep the same sense. We don't write the two different directions of normal, only one sense. So in this case, it is downward. So V2 sin theta is equal to V1 cos theta. So Vx sin theta is Vy cos theta, which is again, and the third method, which is called the organic way of thinking. So I'll just show it here. So this is your wedge. And after some time, your wedge will be displacing from this position to this position. So you can draw two diagrams. And you can clearly see, yeah, you can. Let me remove this part.
Fit down.
So what you can realize with ease that by virtue of displacement in the x, let's say you go by x, the rod can fall by y.
Yes, and that will be constant because of the angle, right?
And this angle having fixed relation, right? So tan theta is y by x. Y is, and because theta is constant, so we can differentiate. So we can get to Vy is. And because theta is again constant, we can differentiate once again. I mean, you can do it directly, but this is just a way of writing. Is this clear? All the three ideas are clear, like how to think about normal constraint. Hello, hello, hello.
Yes, sir.
So let me do this. So the wedge is fixed, but we have one more inverted wedge. And we have a block here. And all the surfaces are smooth. So what will be the direction of M2? Like how M2 can move? What is the constraint for M2 to move? How M2 will move? Tell me quickly.
Along the inclined plane of the fixed wedge.
So there is no option, right? It is so we know first of all we
Yeah.
always figure out the possible directional motion. So this can only go this way, right? There is no choice. And how M1 will move?
Downwards, sir.
Vertically downward like this? Or something
Yes,
like this?
sir, vertically downward.
Yeah, vertically downwards. Because all surfaces are smooth.
Pardon?
Because all the surfaces are smooth, so it should just be
Correct.
vertically downwards.
So because all surfaces are smooth, so the only force acting on M1 is vertical forces, right? Normal and inertia. And due to lack of the horizontal force, it cannot go left or right. And then what is the constant here? How to relate to V1, V2?
V1 equals to V2 sin theta.
V1 equals to V2 sin theta is the right answer. So V1 is already along the common normal. This is the common normal. And because V1 is already along it, so we need to just think of V2. So V2 will have V2 sin theta as a vertical component. Correct? Okay. So we have to think about this point, and along this point, the velocity along this direction must be same for both. This is the constant. And now what if I make it free? Let's say I change this question to way to move M3. Then how the variable should be assumed to make it easy? The previous question is clear to all of you?
Yes.
No matter how, whether the wedge is fixed or free, one thing is clear. M1 will only move vertically downward, right?
Yes, sir.
Because if you think of FBD of M1, there is no horizontal force acting on it. All right. And what will be the path of M2? Because that is now questionable. Can we predict the path of M2? Can we predict the path of M2? Yes or no?
Sir, M2 slides along the wedge, but then it also goes back with the speed of the wedge.
So it means you do not know the exact path, right?
Yes,
So
sir.
basically, M2 will perform the two-dimensional motion. So
Yeah.
M1 is performing one dimension. M3 is bound to perform one dimension. Hello? Yes or no?
Yes.
Yes.
Yes, sir.
So M3 have no choice. No? It will go only right. M1 will have no choice, but will go down. But M3 having choice. It will, so what we'll
Choice,
do is,
yes.
we'll consider two components. One down, one
One
left.
towards left.
And down is going to be same as
M1.
M1 because along the common normal, the velocity must be
They
same.
have to have the same velocity to be in
Yeah, so
contact.
they will go down with the same speed in the vertical direction. So that we cannot change. That's why
But
we can
V2
reduce the
we
number of
cannot
variables.
predict, right?
But V2, V3 are related, conservation of linear momentum. There are no horizontal forces here, right? And in the absence of horizontal force, the acceleration or the momentum in the horizontal will be conserved, right? So in the horizontal direction, the momentum of the system must be conserved, isn't it?
Yes.
Why? Because you have to also think as a whole system. When you solve question like this, you have to think about individual and think about the whole also. And if you think about the whole, you will realize that, okay, there is no horizontal force. So for the whole system, the Fx is 0, which means the momentum in the x is constant. And in the x direction, only two masses are moving. Which one? M2 and M3. So M2 V2 is equals to, and see, I mean, there is no angle involved, so I can also add M2 A2 is, oh, but not because of this reason, because we know that ACM x is summation of AMI AIX upon AMI, and because this is 0, what we can write? Summation of MI AIX equals to, this is the fundamental equation for such question, which one should know. So we are going to involve center mass also in solving challenging question of laws of motion. You have to keep your brain always open. Anything can happen at any time. And therefore, now we have a relation. M2 A2 is M3 A3. Okay. And rest is laws of motion. After this, you have to only write the laws of motion. Nothing else. Nothing else. It is clear? So what will the laws of motion for M1? And one more thing. The constant we wrote for the M1, M2, that along the common normal is same, but there is one more constant. Along the common normal here, it is going to be also same. Right? So now we have to add the two pair of constant. Do you realize this? Because both pair are internal, isn't it? Hello.
Yes.
So can you think that was deep? Okay, that we have to write two pair of constant, and this pair of constant, this second pair of constant is very interesting. And to write the constant, draw a slant, because this is our common normal. Draw the velocity of the individual masses. V3 is like this, and what? And there's something interesting. The M2 will have V1 this way, and I'm going to take the net velocity in this direction as common. This is the common normal. What we are going to write here? Tell me, guys. What we are going to write here? Theta.
V1 cos theta plus V3 sin theta is equal to V2 sin theta.
V1 cos theta minus V2 sin theta equals to V3 sin theta, right? The two will have two velocities, right? So what is the net into the plane, into the common normal? Net is how much? V1 cos theta minus V2 cos theta, V2 sin theta, right? The M2 mass will try to dent the surface with what speed? But the surface is running away with what speed? So they must match. Hello. Do you realize
Yes.
this?
Yes.
Okay. And therefore, it becomes V1 minus V2 tan theta is V3 tan theta. So V1 is V2 plus V3 into tan theta. So we can write as A1 equals to A2 plus A3 tan theta and what else I can? A1 equals to A2 plus A3, which we can write as M2 by M3 You can see we have connected all variables with this. We can add A1 in terms of A2, and definitely we can also add other things. But if you are here, you are almost done. Why? Now we know how to add laws of motion, isn't it? Hello, hello. We know the laws of motion. Yes or no?
Yes, sir.
And what is the laws of motion? For M1, so you have to draw the FBD of M1. It will be M1G minus N, let's call N1 equals to M1 A1. That's correct. And what about the M2? In fact, M1 and M2 are going down with the same acceleration. So I can take as a system. So we can always convert into collection of object into one object if they have common acceleration in one particular direction, and then write the laws of motion for the entire system. That will reduce the effect of writing the individual normal, right? What I mean to say that, it's difficult. I'm saying that can we treat this entire part as one part? And if you think that as one part, the downward force is how much? The downward force is M1 plus M2 into G, correct? And the upward force is going to be this normal, which is how much? If you remember, this normal is always the component. This is theta, right? Upward is how much? N cos theta. Hello, hello, hello. And this net force equals to net mass into which acceleration we should write here? A 1, 2, 3. Which one?
A1.
A1. That's it. And therefore you can see A1 is how much? A1 is basically G minus N cos theta upon M1%. Wow. See, we got A1 in terms of N, which is common variable. And then what about this wedge? For this wedge, if you draw the ability, it is N sin theta acting in the horizontal direction, right? And that will give you the acceleration how much? M3, A3. So what is A3 now? N sin theta by. So you know A1, you know A3. Okay. You know A1, you know A3. And not only this, you know other relation as well. And okay. Yeah, I mean that become a bit cumbersome, but energy and this and the same normal. I mean, of course, you can add for the middle wedge. For middle wedge, what is the net force in the left? Any guess? It is N sin theta again,
In sin theta, yes.
which is M2 into A2. Correct? A2 is N sin theta by into C. I can get all values of A1, A2, A3, all in terms of single variable N. So what is the next step? I will take this, and will put it in my single constraint, and I'm done. I'll get the N. And with that N, I can solve all questions. Hello, hello, hello. Is this clear? So
Yes, sir.
this is like the tough question. I mean, the challenging problem. If you see the question like this, they will generally give you the simple masses, like all are M masses. So M. So it means you know how to play with. If all are same mass, then V2, V3 becomes same. Correct? So A2, A3 will be same variable. So number of variables will reduce drastically. because of this simplified assumption. What I tried is I tried to solve the general assumption. Like you can also solve the 3-block problem when all are free to move. And the process is same. I always look for the common universal variable in which things can be expressed. Why? Because we don't have 2 variables. It's a 3-variable problem. We have constant with A1, A2, A3. And the moment we go from 2 to 3, it is always convenient to convert into a single variable problem. And that is why we substitute A1, A2, A3. So earlier we used to substitute in terms of tension, and now we are substituting in terms of normal. Is this clear? Hello.
Yes, sir.
Yes.
So I'll just quickly solve one question before I leave for the day. And I'll show you some advanced method of solving wedge and block problem without using resolution. Okay, I thought it's 816. It's a 916. Theta. So this is capital M, this is small m. You all have seen this question, right? And friction is 0 everywhere. How to solve this question? So first of all, you need to learn how to assume variables. And it is easy. We know that this will go with what accession A, that we can assume like this.
Yes.
We have no idea how M will move in ground frame. So we
We can
know
take
that,
two.
yeah, we know that it will move in the wedge frame like this. So I name it as AR, the relative accession. But a wedge itself is moving with A. So the block will have 2 accession, AR and A like this. It is clear?
Yes, sir.
Yes.
And then I can resolve this as theta. This will become A cos theta. This is A sin theta. Now tell me, for this block, what is the net accession in the ground frame along the plane? What is the net accession like this? It is AR minus A cos theta. Do you realize this?
Yes. Yes.
And we know that for any block down the plane, the net force is mg sin theta.
Yes.
So this is the answer. So this is the relation that AR minus A cos theta is actually G sin theta. What I did, I wrote net force upon mass, which is G sin theta, right? In ground frame. So we are solving in ground frame. There is no pseudo force. Do you see any pseudo force here? Hello, hello.
No, sir.
See, pseudo force is not at all required. See, laws of motion can be solved without using pseudo force for any question. So generally, I use only for 1 or 2 questions in circular motion, but for 99% question, you can always avoid pseudo force. In fact, one should not learn pseudo force. That's a very bad way of learning things. Okay, so we got the answer. What is the next step? The next step is, how many of you realize this part? Tell me. If you have doubt, I can explain. All are okay?
Understood.
And the next part is simple. We know that net force on a system in the X is 0. So AMI X AIX summation is, that's it. You can use this answer. So capital M into A must be equals to small a into AR cos theta minus A. Hello, hello. Is this clear?
Yes, sir.
And I'm done. MA, but M plus M into A is M AR cos theta. And what is AR by the way? So they never ask AR, they ask the A only. What is the accession wedge? So AR we can replace by G sin theta plus A cos theta. From the top equation. Right? Hello? And see, I'm done with the question. M plus M is M G sin theta cos theta plus M A cos square theta. Okay. So m plus m minus m cos square theta whole into a is mg sine cos, and we know this famous answer. Mg sine cos upon capital M plus m sine square theta. So this is the answer without using log of motion. You can always use this idea. Of course, this is the log of motion. So it's wrong to say without log of motion, but without writing the too many equations. Okay, I'm writing the question. Anything. It is clear?
Yes.
Or if you
Yes.
want to solve by the even more orthodox method, I can tell you how to write this. You can say that for the block I can write mg cos theta minus n equals to m into a sin theta. See, I'm writing the log of motion in this direction. Something very strange you have never seen. And then I can write the next step in one line. N sin theta equals to capital M into a. I'll just substitute here. I'm done. In one line. So all methods are easy, right? This is even easier. See, no pseudo force. So do we need pseudo force to solve a question? The answer is no. So you can solve by the method you want. There are many methods. Always think in terms of ground frame and you're done. And see here, I haven't used anything like pseudo force something. So the laws of motion part is done, and we have seen the other constant relation. Your homework will be what? So laws of motion exercise 2 part 2 finish everything. Okay. I think that is sufficient to understand the concept. And if that is very difficult, then solve the exercise 2 part 1 first. It is up to you. Okay. And you can solve even 3 block, 4 block problem. Doesn't matter, like whatever be the number of block, you can always solve in the ground frame. And pseudo force is not required. If you want, you can solve. And pseudo force is just a technique, right? Method. All right. So next class, I will show you some advanced question of friction and circumference. Okay. Friction will be very easy. Very easy means very easy actually. Okay. So read notes. I have shared the notes of all chapter, right?
Yes.
Like friction, circular motion. So make sure that you not just read the notes, but you have to start solving all the 3 chapters, the PYQs, and if you want to go more deeper, then this resonance sheet.
I will start after Monday.
That's fine. That's fine. I mean, the idea is, see, if you have more time, then resonance. If you have less time, if you're not able to manage time, then only shift to the PYQs. The previous year question, that is up. Okay. All right.
Bye.
Bye. Good night.
Good night,
Bye,
sir.
sir. Thank you, sir.
Okay. Bye.